Hi there. So, for situations where dealing with quadratics isn't so nice, isn't so obvious, really for me, any situation where it's not clear from context what should be done, you can always use the quadratic formula. X equals the negative b plus or minus the square root of b squared minus 4ac all over 2a. Where, in case you're wondering, I was whistling Pop Goes the Weasel at the start there because that is how I remembered the quadratic formula since my freshman algebra teacher taught it to me like, I think it was 12 years ago now.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
It's been a long time. The point is, I still remember it. It helped me a fair amount. It may help you. So if you ever have trouble remembering what you do there, or whether that's a B or whatever, just think about weasels, I guess. I don't know. That felt less weird in my head. But anyway, let's get an example for why we might want to know this. So let's solve 5x squared plus 2x plus 1 equals 0. So here, a is 5. And right off the bat, that's going to make both factoring and completing the square a lot less fun. This is also obviously not a perfect square. Plus, c being 1 means that if you want to factor 5 and 1, you're going to have some really nasty radicals in there, even if it does get to something useful. Basically, when I look at something like that and I can't see that, okay, I've got a clear path, just take the quadratic formula. Because the quadratic formula, as long as you remember the pieces and you don't screw up your algebra, will always take you to the right answer. It might not be the nice answer, but it will be the right one. So, if we want to do that, we just have to note for ourselves that a, in this case, as I said, is 5. B is equal to 2, and C is, in this case, 1. So via the quadratic formula, we have that x is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 5 times 1 all over 2 times 5. Or x is equal to negative 2 plus or minus the square root of 4 minus 20 all over 10, or x is equal to negative 2 plus or minus 4 minus 20 is negative 16. Square root of negative 16 using our notation is 4i all over 10. And then if you want to simplify it a little bit, you could say that this is equal to negative 1 plus or minus 2i over 5. Where in this case we will have complex roots. We will have 2 of them. I'm not going to write the solution set here just because it would be clunkier than this already is. But it would be in terms of negative 1 plus 2i over 5, quantity over 5, or negative 1 minus 2i, quantity over 5. Either of those works. Where this value in here, underneath that square root, is particularly relevant for being able to determine what kind of roots we're going to get. That is a thing called the discriminant, and we'll spend a little bit more time on that next.